All right, so 9.3 exponential functions. So first in this section, we're going to learn about Euler's number. That's that little fancy E you see in some of the math equations. This is called Euler's number. And it's approximately equal to 2.71828, 1828. But this is like pi. This number goes on forever and ever. So this is just what my calculator gave me on that one. We're not going to learn a lot about it, just use it in a few of our formulas and stuff. If you take business calculus or business math, they'll teach you more about this constant E, okay? It's used in a lot of interest rate type problems. So what we're going to do tonight, some of the problems have you rounding things off to like the nearest thousands, nearest 10,000s. So I'm going to recall y'all. On just some placeholders. So the one right here, that's in the ones place on the left of the decimal. And then if I kept going left, I would get the tens, hundreds, thousands, and so on. But what I want to work with is on the right side. So the first digit after the decimal is the tenths. T-E-N-T-H-S. Next would be the hundredths. So they're sort of the opposite going this way. They add TH for the tenths because remember, on this side of the decimal is almost like fractional numbers, okay? 3 would be the thousandths. 4 would be the 10,000ths. And then it would keep on going. 100,000ths. Millionths, all these have a TH after them on the right side, okay? So, knowing that, I want y'all to round 2.71828, 1828 to the nearest 10,000ths. So notice the 10,000ths, that's the fourth decimal place after the decimal. So we got 1, 2, 3. The fourth decimal place is the 2 on my problem. So remember, since they want me to round to the 10,000th spot, I got to look at the next digit to determine what I do. If it's 0, 1, 2, 3, or 4, I would leave this 2 the same. If it's a 5, 6, 7, 8, or 9, I would round that 2 up. So since I got an 8 following the 2, this would round off to 2.7183. So they're going to give us, when you first start this homework, they're going to give you 2 problems playing with that E. So let me show you where E is on the calculator. So I'm going to share that screen. All right, y'all, there's 2 places you'll see the E on the calculator. The first place is right above the division. On the right side, there's a little blue E. If you hit the second button and then the divide button, it'll pull the E on the screen. And y'all, when I hit enter, there's that 2.71 that I was playing with a while ago. Now, the second place, say you got an exponent like E to the third or E to the fourth. If I'm doing exponents with E, down here you see to the left of the 4 on the calculator, there's the LN button. And we'll learn about the LN button later on in this chapter. But right above it is a little E with the X where the exponent is. If you hit the blue second button and then that LN button, it'll bring the E on the screen with the exponent flashing. So all I got to do, say this was E to the second, I would push my exponent 2 and then hit enter and it'll give me that value. So y'all let me go back now to our paper. So that's where it's located on your calculator. So for these first two examples, they want us to use a calculator to approximate the exponential expression to 4 decimal places. So now in MATLAB, so let's see, this first problem is E to the third. So in MATLAB, they're going to use the squiggly looking equal signs. When you got squiggly equal signs, that means we're approximating. Because remember, these are never ending decimals, so you can't be exact on the answers. You just round them off and approximate them. So 4 decimal places, well, guess what? 1, 2, 3, 4, that's going to be the 10,000ths. So they're either going to say round to the nearest 10,000ths or round to the nearest 4 decimal places. All right, y'all, so I would go to my calculator and hit E to the third. So I'm just going to put this one right here. So let me clear that E off. So E to the third, since I got an exponent, I'm going to hit second LN to bring the E up with the exponent flashing. Put in my 3 for my exponent and hit enter. So I'm going to write all this down real quick. So I got 20.08553692. All right, so that's what the calculator gave me. But remember, I've got to round that 4 decimal places. So let's see, 1, 2, 3. The 4th decimal place to the right is a 5. Which means I need to look at the 3 that follows the 5 to tell me what to do. So since the 3 is less than 5, I'm not going to round that 5 up. I'm going to leave it the same. So I would get 20.0855. Now y'all watch, remember, they're either going to say 4 decimal places or round to the nearest 10,000ths on these. So y'all got a question about finding E on that calculator? Because that's pretty much the only way you're going to be able to do these problems. You just can't do these by your head, okay? All right, so this one says approximate to the nearest 10,000ths. So this one, they're actually telling you the 10,000ths like we learned up here. And they're giving me E to the negative 3.45. Now, we'll say this. When the exponents are positive, you'll usually get a nice number greater than 0.02. Now, when it's negative, you're going to notice negative exponents cause you to get what I call numbers less than 1. So y'all watch this. I'm going to hit second LN to get my E with the exponent. I'm going to put in a negative 3.45. Hit enter. So let me see what I'm getting. I'm getting 0.0317 456 364. All right, so the nearest 10,000s, here's my tenths, hundreds, thousands, 10,000s. Once again, is the fourth number, 7, which means I need to look at the number after it, which is a 4. So 4 is still less than 5, so I will not change that 7. So this would be a 0.0317. So y'all, that's how it's going to start out with Math Lab, and then it starts getting you into doing a few exponential graphs. So let's learn about exponential graphs. So graphing exponential functions. So these will be in exponential form. So you'll have y equals a to the x. The variable is going to be the exponent in these problems. The a, where the a is, we call that the base. That's the number getting multiplied by ever how many times those exponent tells us. Okay. All right, the variable is the exponent. Now, y'all, a good thing to remember in this section. Do y'all remember what anything to the 0 power equals? So that could be 2 to the 0, 3 to the 0, 4 to the 0. They all equal the same number.
Is it 1?
It is definitely a 1. Which means no matter what this base is, when that exponent is 0, that y value will be 1 for those, okay? So that's the property of these exponential graphs, is that they all pass through 0, 1 unless we move them around, okay? So let's play with one of these. We're going to graph y equals 2 to the x. This way you'll sort of know what tool you got to use in MATLAB for these and what's happening with them, okay? Oh, y'all, I'm going to go at about 10 on this. Okay, so I'm just going to make me a little table up. So I'm going to pick some numbers to the right, and then I might pick a few of these negative numbers. So another property about these exponential graphs is that their domain is all real numbers. Any negative numbers I can put in for those x's, any positive numbers I can put in for my x's. All right, so one I'm going to pick is 0. So what will my y value be when I put a 0 in for that x?
1.
So that'll be 1. So this thing will pass through 0, 1 on the y-axis. All right, let's see, if we put a 1 in there, that is 2 to the first power. We know anything to an exponent of 1 is itself. So 2 to the first power will give me a 2. So when x is 1, y is 2. So let's try another one. Going this way, I just want y'all to sort of see a few things happening. So if I put a 2 in there, 2 squared would be 2 times 2, which is 4. So when this is 2, it's going to 4. So y'all can see what's going to happen. It's going to start increasing pretty sharp if I throw an exponent 3 down there. That is 2 to the third power. So 2 times 2 times 2 is going to give me an 8. So by the time I'm at 3, this thing is sitting up here at 8. So notice exponential graphs have a tendency to start getting a pretty steep slope going on, okay? And y'all remember COVID, they talked about doubling rates. Well, look at these Y values. They're starting to double. 1 to 2, 2 to 4, 4 to 8. Next would be 4, 16. So they start doubling pretty quick like that COVID did on those graphs. So now, let me show you what happens if these exponents are negative. So y'all let me play with that in here. So 2 to the negative 1. Now you can do this on the calculator, but let me show you how to deal with negative exponents. When you got negative exponents, you put your expression under 1 and change the negative exponent to a positive exponent. So to make exponents positive, I just throw them under a 1. And then 1 over 2 to the first is going to give me 1/2. So at negative 1, my Y value is 1/2. So here's negative 1. 1/2 is about halfway in between 0 and 1 on the Y-axis. And let me just do one more just to show you what's happening on this left side. So I'm going to put a negative 2 in for my X. Remember, make the exponent positive by putting that under a 1. So the top will be a 1. The bottom's 2 squared, which will give us a 4. So when X is negative 2, this is 1/4. So let's see, negative 2, 1/4 is just barely going to be there. So what happens on this negative side, this graph is trying to get closer to the x-axis, but it never can cross it. It can get closer and closer. So these values will go from 1/2, 1/4, 1/8, 1/16. The bigger that negative exponent, the closer to 0 they are. So these graphs will come sort of like a horizontal asymptote, come up, cross over at 0, 1, and then start increasing towards infinity. And y'all seen how fast these grew when we had that COVID, right? So that's going to be the shape of the graph tool you pick in MathLab, is that little curvy looking line. And I'll show you after a while when I have to graph these. But for these first few graphs, they just give you 4 pictures and you pick the one that looks like your graph, okay? So those will have like an A, B, C, D. So now let me show you the other type you'll have. So no matter what the A is on these, when it's a whole number like that, your graph will go uphill left to right. Now, when we get a fraction such as a 1/3 to the X, let's see what happens on that one. I'm just going to make this and go out about 5, I guess. All right, so I'm going to set me up a little table, X and Y. Now, y'all, let me show you that last one. If you wanted to graph that, let me go to that calculator real quick. So 2 to the X, I'll just go to calculator, go to my Y equals, put in my 2, hit the little upside down V for the exponent, and put in my X. Now, when I hit graph, it should look pretty similar. There you go to what we had. Now, if you look at the table, second graph for the table, notice down here, 0, I got a 1, 1, 2, 2, 4, and so on. And then go toward the negative direction. Look how these numbers are getting closer and closer to 0, but they never will get to 0, okay? All right, so the calculator's nice on these kind of problems. So if you do the fraction one on the calculator, make sure you put that fraction in parentheses, okay? All right, y'all, so I'm gonna put a 0 there. So what is 1/3 to the 0 power? Oh, y'all can say it.
1.
It's 1, no matter what that is. If it's got a 0 after those parentheses, it's going to be a 1. So 0, 1 again. Now watch the difference. If I put a 1 in there, this is 1/3 to the first power. Well, 1/3 to the first, anything to the first power is itself. So that's going to stay 1/3. So right here at 1, we're about 1/3 on here. Let's put a 2 in there. That would give me 1/3 squared. Well, fractions raise the exponents. You square the top and then you square the bottom. So 1 times 1 on top is 1. 3 times 3 on bottom is a 9. So when x is 2, I get a 1/9. Ooh, that's pretty tight down there. Close to the x-axis. So the further I go right, it's just going to keep getting closer and closer to the x. So let's play with a few negative x's and see what happens. 1/3 to the -1. Now, remember up here, I put everything under a 1 and change the sign of the exponent. When you got a fraction, you flip the fraction. So make this a 3/1 and change the exponent to a +1. So fractions, you flip them to change the sign of the exponent. Well, y'all, this is 3/1, which is 3 to the first power, which is going to equal 3. So when x is -1, my value is 3. Let's try -2. Now, y'all, that calculator does these, watch. So if I had my 1/3, that would be 1 divided by 3, close parentheses, exponent, -1. That gives you 3. So watch this. If I do 1 divided by 3, exponent -2, that's going to flip that and make that a 3/1 squared, which will give us 9. So if you notice, at -2, I'm way up here at 9 somewhere. But all it does, fractions, instead of going uphill left to right, your fractions will go downhill left to right. And it'll come trying to get down and do a horizontal asymptote. So numbers greater than 1 increase, numbers less than 1, like fractions, decrease left to right. So y'all, they'll have y'all draw a few graphs and pick out A, B, C, D on those. But remember, all these you can graph on that calculator. So let me go to my main screen and I'll do the fraction on that calculator. So let's go to y equals and clear that. You just got to remember, put that fraction in parentheses. And then it was what, 1/3? So 1 divided by 3. Close parentheses, and the variable for the exponent was a x. So now when we hit graph, watch how it goes downhill, left to right. So what's nice is y'all don't have to physically graph this section, okay? You just got to pick out a picture. And you can almost get those by just knowing what these basic shapes were we just went through. All right, y'all, so then we get into our translations. So I'm still playing with these, y equals a to the x, my exponential graphs. So translations are when we move them up and down, left and right, and we reflect them. So these are similar to the ones that you had in 8.1. So my first translation is a vertical shift. To create a vertical shift, we'll have y equals a to the x plus or minus b. So it'll add or subtract the number to the end of the function. If b is positive, well, remember, if b was positive in section 8.1, it moved the graph up. So if b is positive, you're going to go up. If the b is negative, it's going to move it down. And that's exactly the same as it was in 8.1. When y'all had the x squared graphs, if you added or subtracted at the end, it went up or down. The second possible shift is a horizontal shift. That'll be in the form of y equals a to the x plus or minus c. So I'm attacking the variable. This is similar to when the variables were in parentheses in 8.1. If you attack the x, it moves me left or right. So if you attack the x and c is positive, it's going to do like it did in 8.1 and move my graph to the left. If you subtract c from the exponent, it's going to move your graph to the right. So just like 8.1 or 8.2, when you attack the x, it's sort of backwards what you think, but when you add is left and subtract is right. Now the third translation is a new one. This is a reflection over the y-axis. So to flip a graph on the y-axis, you would have the form y equals a to the negative x. So if that's a negative x, then it's going to reverse all the values, and instead of going uphill, it's going to look like it's sort of going downhill when you reflect it. And y'all, just a reminder, the reflection over the x-axis. Remember, to reflect it over the x-axis, you had y equals negative a to the x. If you put a negative in front of that base, it's going to reflect it over the x-axis. If you put the negative in front of the exponent, it's going to reflect it over the y-axis. So y'all remember these moves, because I'm about to flip us into the math lab to show you how to graph on it, okay? All right, so let's share our screen and get into the math lab. All right, so sketch the graph of the function. So they're going to want us to graph this. But before doing that, they want us to describe how it can be obtained from the graph of a basic exponential function. So what we got to do, notice I'm attacking that x by adding 2 to it. So first off, what will that do to my graph? Up, down, left, right, over the y, over the x.
We'll go left.
So that's a positive 2, so it's going to go left. So let's see, left will be C, so I'm going to click C. Now, in that box, it says start with the graph of y equals blank to the x. That's where you put your base. So since ours was a base 2 up there, we put a 2 down there in that box. And then we're going to shift it to the left, it says. Now, when you check that answer, it's going to continue and have us graph it. So here's the thing on the graph. Click to enlarge the graph. The tool you're going to use is on the second row, second option. When you click on it, it says exponential tool. So click that and then click anywhere on that graph. It's going to put it in the center going through 0, 1 on the y-axis, because that's the basic graph. So we're going to move that by going down here. You said left 2, so we're going to go horizontal and move that left to -2. As I do that, notice my graph moves left. Now, here's where people get in trouble. Down here on the very bottom left of this box, it says base. It has the E in there by default. We have to go into that box and backspace on that and change it from an E to a 2. It's got to match your base on your problem to get this right. Now, once you change your base, you hit save and check answer. And then it lets you get to the next question, okay? But y'all, very important that you change that base. All right, so y'all should be seeing my next one now. Sketch the graph of f of x equals 2 to the x plus 2. And then we'll describe how it can be obtained. Well, in order to graph it, you got to know what that plus 2 is doing to my graph. So y'all, if I add a 2 to the end of that function like that, what is that doing to the graph?
Going up.
So it's going to go up. So we know that's going to be up. So we click the tool, looks like the curve, click on the graph. It was going to go up, what was that, 2 on that one? So go to vertical and go right to 2. Whoops, too far. So there's 2. So am I done?
No.
So what have we got to do?
Change the base.
Change the base. So my base on this one was, what was that, a 2 again? So I'm
Yeah.
gonna go from here, backspace on that, put my 2 in for my base, then save it. Now this one, watch, it's sort of backwards from the first one. You graphed it first, and then you got to fill in the box. So the graph is the basic function, y equals. Now be careful, you don't want the 2x, the top answer, you want the second one that has the 2 with the x as an exponent. Click on that, and then do what you said, shift it up 2 units. So they'll have you playing with a few of those, okay? So let me do one more. This one was tricky. So sketch the graph, then we get to tell about it. So my base is a 2 on this one. There's a positive 1. So remember, 1 minus x is the same thing as negative x plus 1. They're just giving it to you out of order. So that 1 being positive is going to move me left 1 unit. There's a negative in front of that x. That's going to reflect me over the y-axis. And then y'all at the end, that plus 3 is going to move me up 3 units. So I'm going to put the, now, let me move where I can see my actual problem. Now, you're still going to pick the exponential tool, the little curvy, click in the graph anywhere. So I do the moves in order. So the 1 was first, the 1 was positive, so I'm going to move left horizontally 1. Then I had the negative x. Well, remember that negative x reflect me across the y-axis. So I'm going to click that right down here in that box. Then the plus 3 move me up 3 vertically. So I would go to my vertical and bring it up 3. So now my graph is all moved. My base is a 2 down here. So I guess it kept a 2 from a while ago, right? So my base is 2 is good, so save that. And then you got to check that answer before it lets you do the part B, and that's how to describe it. So let's see. Now be careful, because this one went left 1 unit, but then it says reflect across the x. We reflected across the y-axis. So both of these have left 1 unit, so you couldn't have missed that, I guess, on this part. reflect across the y-axis, and then we went up 3, so that one goes down. So I would have to go with C on that one. That went left 1, reflected the y-axis, and then up 3. So at that point, you check those, and then you move on to your next one. So I'm going to do this one. Now, I'll tell you what will help you on this. They got 3 minus 2 to the negative x. So I'm going to write this one down and show you what I'll do on paper. So let me go show you what I'll do to that one. This is the last of the really tricky ones. So the one I just did was out of order on the x's. Remember, it had 1 minus x. This one is out of order on the numbers down here. This is the same thing as a negative 2 to the negative x plus 3. Move that 3 to the end. Then it's easier to see what's happening. I got a negative in front of the 2. That's going to reflect me on the x. That negative up here in front of the x is going to reflect on the y. And then that 3 at the end is going to make me go up 3 units. So put this one in order and you'll have all the moves right there, okay? So there's that x, the y, and then up 3. So now we want to go play with this on MATLAB. So notice what it says. You got 3 answers. Across the y-axis, then across the x, and then shift it up 3. This one says across the y-axis, shift it down 3. The last one says across the x-axis, then shift it down 3 units. Well, remember, we got to reflect over all the axes. So we are reflecting across the y, across the x, and we're going to shift it up 3 units. So we got to go with A. That's the only one that's got all 3 of our moves. In the box, you put your base, which is a 2. You don't have to put the negative there. The negative is taken care of with these moves they're doing. The only base you want in there is that positive 2. So check that. Then you know it's going to make us graph it, right? So now we click to enlarge the graph. And y'all, I do my moves the same way as they got them in our answer. I'm going to click my tool. Click in the center of my graph anywhere. So remember, the first thing I did, I reflected across the y-axis. Then I reflected across the x-axis. Then we went up 3, so that'll be a vertical shift to positive 3. Remember, I got to do one more thing on this. I got to go down there where that base is, because this time it's got the E again. So let me backspace the E and put a 2 in there. All right, so then you would actually just save that, check your answer, and move on, okay? All right, so I'm going to go back to my paper for the last few things I got. All right, so play with the tools on that to get those, okay? So this last section, there's 2 problems dealing with a formula. And this is an exponential type formula. So we're going to play with this formula. A of t equals. Now this is the formula for how much money is in an account after a certain interest for a certain period of time. So t is in years for these, okay? That's my time. The formula is P times 1 plus R divided by N, all raised to the N times T exponent. T in this formula is time, and we're talking about time in years. P is what we call the principal balance, and the principal balance is basically your starting amount. R in my formula is the interest rate. Now, the interest rate has to be in decimal form, not in percent form. So remember, to change from a percent to a decimal, I move the decimal left 2 units. And I'll give you a few examples doing that in a second. The N in this formula happens twice. It is the number of compounds per year. That's the number of times they hit that interest on you. So you'll see words like annually, which would be once a year. Semi-annually would be twice a year. Monthly would be, 12 times a year. Quarterly would be 4 times a year. And daily would be 365 days or something like that a year. All right, so let me get y'all good at doing, so recall. We're going to turn 25% into a decimal. So remember, in this form, the decimal would technically be after the 5. But since I don't have nothing but zeros after that, I don't have to put the decimal. So if one's not shown, it is definitely behind that last number, like the 5. So you got to move it left twice. So that'll give me a 0.25. And then you get rid of the percent stuff, okay? So let me do another one. How about, what if I had 5 1/4%? First thing I would do is turn that 1/4 into a decimal. So 1/4, if you did it on the calculator, would give you a 0.25. So I convert it from fraction into decimal, then I move that decimal left 2 units to get my decimal form for my problem. So remember, I could only move it once on this. I got to add a 0 to move it twice. So this one would be a 0.0525, okay? So convert the fraction over, then move that decimal. All right, then finally the A of T up here is the amount in the account after T years. So say I did an investment and I wanted to know how much I'll have in 5 years. I could put a 5 in for the T's, work my formula, and see what I get, okay? So let's play some examples. So there'll be 2 of these. So the first example says, suppose $57,000 is invested at 5.5% interest, compounded quarterly. So A on this, part A wants me to find the function for which the investment grows after T years. So they won't want us to solve it. They just want us to come up with the actual formula. And then I'll show you how MATLAB wants this answer. So the formula will start out A of T. Now, MATLAB will put the A of T down there. You just got to put everything else when we're done. So y'all, we're starting to fill in for this formula. P is my principal balance. My starting amount, well, that's going to be that 57,000. Then we had parentheses, 1 plus R divided by N. So y'all, for this problem, R, we got 5.5%. We need to turn that into a decimal. So if you punch 1/2 on the calculator, you'll get a 0.5. So this is 5.5%. So what would that turn into in decimal form?
.055.
So that'd be 0.055. So that's going in for our R. So N is the number of compounds per year. So it's quarterly. So what would N be?
4.
All right, so let me put my 4. And then you got your 4 for the N again, times T. So now, although this is correct, you see this part inside the parentheses. MathLab wants you to figure that out for the final formula. So we'll have 57,000. So right here, we got to figure out on the calculator 1 plus 0.055 divided by 4. So let's see what that equals. That's 1.01375. So you got to put that into parentheses, 1.01375, and then 4 times T. So they want you to figure this part out in parentheses. Now, all I got to do is plug in for the T, and I can tell how much money is in that account after that many years. So remember, MathLab, simplify those parentheses. So that's my function. Now, part B of this said, hey, find the amount after T equals 0, 2, 5, and 10 years. And this one says round to the nearest dollar. So no cents or no decimal stuff when they say round to the nearest dollar. So let's see, we're going to figure out what it is for T equals 0, T equals 2, T equals 5, and T equals 10. Well, y'all, how much? So let me ask y'all this. At T equals 0, if no time has passed, and you started with $57,000, if no time has passed, how much better be in that account?
57,000.
57,000. Because remember, so if you put a 0 in here, 4 times 0 is 0. 1.01375 to the 0 power is 1, remember? And then 1 times 57,000 would give us our 57,000. But y'all watch this. Calculator can do these. 57,000 parentheses 1.01375 close parentheses exponent 4 times 0. So when I punch that in, there's my 57,000. Now you can punch all these in that way and get answers, but y'all, I'm going to show y'all an easier way to get these answers. And it's using the graph features. So watch this. I'm going to go to y equals, clear that out. I'm going to put in my 57,000 parentheses 1.01375 close parentheses. My exponent is 4 times. Now the only thing is when you're using the calculator, use the x for your variable. Okay, because it graphs with y's and x's instead of t's and all that fun stuff. So make sure you use the x for your variable. Now we're not going to see this graph. When I hit graph, we're not going to see the graph because this thing's starting up at 57,000. My y's only go to 10. So What I want to do though is show you a feature of it. Although I can't see the graph, I can still find the values of the x's. So you see right above this trace button, it says CALC. That does calculations. So since that's in blue, I'm going to hit second trace to pull up these calculations. And I want the value, which is the first thing on it. So for value, you hit enter. And it says, hey, what is your x? So remember, my first one was 0 for t. So that means my x would be 0. When I hit enter, look at that y value, 57,000. Now I'm going to go to second trace again, hit enter for value. This time my x is going to be 2 since my t was 2. And remember, we're rounding these to the nearest dollar. So I got 63580.18 cents. So since I got a 0 in the last spot, after the decimal is a 1, I do not round it up and I keep that 0. So this would be 63,580. But y'all remember, you can still go back and do these on here. 57,000, 1.01375. Raise that to the 4 times 2. And we still get the same thing. Okay. So now I'm going to go back to that calculation when I put a value of 5 in there. Now remember, this is an investment, so these better be getting bigger every time. All right, so let's see. 74901.7. So if I'm rounding to the nearest dollar, that's going to be 74,902. I got to turn the 1 into a 2 because of that 7. So 74,902. All right, then one more time, second calculation, hit enter for value. This is 10 years. So let's see how much money is in this account after 10 years. We hit enter. And let's see, 98,425.9. So once again, the 9's 5 or greater. So I'm going to round that 5 up to a 6. So I got 98,426. So that's not bad. You almost doubled 57,000 in 10 years. So that ain't a bad little investment, is it? All right, so you want to write this formula down for these two problems, okay? This one and one I'm about to do. Okay, this one says, on Melissa's 6th birthday, you know, I like doing these sort of what we call application problems so you can sort of see this, how we use these kind of formulas. So on Melissa's 6th birthday, she gets a $6,000 CD that earns 6% interest, compounded semi-annually, now, if the CD matures on her 16th birthday, how much money will be available? So we're still using that formula. A of t equals P times 1 plus R over N raised to the N times T exponent. So we got to figure out T. Y'all, what is T for my problem? If she gets this on her 6th birthday and it is matured on her 16th birthday. What are y'all putting for T?
10 years.
10 years, good job. So in this problem, we're going to find the amount at 10 years. All right, my principal, they gave me, oh, what was that? That was up here at 6,000. That's my starting amount. Parentheses, 1 plus. So y'all, what is my R if it is 6%?
0.06.
0.06. That's going to give me 0.06. N is my number of compounds. So what is semi-annually?
What is that, twice a year?
Twice a year. Good job. And then up here would be 2 times T, which is my 10 years. So now, since we know the time, we can work this problem and it's actually going to give me an answer. Now this one, they want me to round to the nearest cents. So round to nearest cents. So that means 2 decimal places when they say cents. You're going to have like a point, blah, blah. All right, so you could graph that, but since I only need one answer, I'm probably just going to punch that in my calculator and see what that thing gives us, okay? So we got 6,000, parentheses, 1 plus 0.06 divided by 2, close those parentheses, and then our exponent would be 2 times 10. Now, y'all, let me say this. If you got an older TI-83, so on the older 83, when you do exponents, it does that to your screen. On yours, you got to put the 2 times 10 and close parentheses. If you don't, it'll only square it, and then it'll multiply your whole answer by 10. So on the older calculators, when it gives you the arrow up in the parentheses, put in what you got and then close your parentheses, okay? All right, y'all, let's see what this thing's going to give us. It gives me, what's that, 10,836.667. So if I'm rounding to the nearest cents, so the first part's going to be 10,836. What's going after that decimal?
$0.66. Or are we rounding?
So
So
we're going to round. So
7.
round this off. So if you round it, what are you going to get?
67.
67. There you go. So remember, nearest cents, they want 2 places. And since that was a 0.667, we had to use a 7 to work on that 6. So y'all, that's 9-3, not too bad. Your homework will go through what we just did in this lecture here. So sort of a mild week because y'all got a study guide. I want y'all to do that study guide until y'all get good and then knock out that test 3, okay? This 9-3 started our test 4 material. And test 4, I don't think test 4 is due until after the Thanksgiving break. So the next couple of weeks, we'll do 9, 4, 5, 6, and 7. And then y'all, you'll pretty much have all my material before, oh, what is it, Thanksgiving break, because we're out that whole week. Once we come back from Thanksgiving break, we'll review for test 4, and then we're going to start reviewing for that final exam. Final exams, all multiple choice. So you don't have to mess with trying to graph in the final or, you know, am I putting my answers in right? You'll have an A, B, C, D choice on it. And remember, the final will replace one low test score for you, okay, if you got one. And y'all ain't gonna lie, most people do really good on the final compared to the other 4 tests, okay? At the end of the year, I also will drop 2 low homework scores from the college algebra portion and from the support portion, okay? So doing that usually helps y'all out just a little bit also. So let me see, do y'all have any questions
Can you repeat that last part again?
about the final?
Yes.
Okay, so remember on the final exam, since it's multiple choice, people usually do better on the final exam. So I replaced 1 low test score with the final exam grade. So say you didn't even do a test and it was a 0. Well, if you scored, say, a 90 on my final, I will turn that 0 test into a 90%.
Okay.
Or any 1 low test. Now, some of y'all are doing pretty good, so y'all might have like 85, 90, 95 type tests. Well, still, if that final's higher than one of them 4 low tests, your lowest one, which was the 85, I guess I just said, it'll turn that 85 into whatever you get that's higher. If your final exam lower than your lowest test, then I won't change nothing, okay? And then I said, at the end, I also will drop 2 low homework scores from the college algebra portion and from the support portion.
So that would be a total of 4.
Yeah, altogether. 2 from the ones that look like a college algebra, and then 2 of those that said support on them.
Okay, thank you.
Okay. All righty, also, anything else?
No, that'll be all for me.
All right, so let's see, we come back, we'll start 9.4 on Monday. And y'all, let me stop my recording and I'll get this out in about